Okay, so this is part 2 of the review. Alright, day 13, part 2. So here we go. If I want to find -4d, that's -4 times d. That just means multiply all these by -4. So that's going to be -12, +8, -4, okay, -16, alright, +4, and -8. Okay, just multiplied each entry by -4, that's what that means. Now we have to do A minus D. Normally when you subtract element minus element. But what will we do when we get to these elements over here? There are no elements over here. So hopefully you know that you cannot add or subtract matrices unless they have the exact same dimensions. If this is a 2 by 3, then this has to be a 2 by 3. So this is undefined. Alright, simply undefined. Let's see, can I do C minus A? I should be able to do this because they're both the same shape. Alright, they're both 2 by 2. Be careful of the order, okay? This is C minus A in that order. Okay, so it's C minus A, so make sure you're doing it in the correct order. So this is just going to be a 2 by 2 matrix, just like the two original functions, but 2 minus 6 is -4. 3 minus -4 is 7. Did you catch that? 3 minus -4. Minus and negative you add, so that's why I'm getting 7. Same thing is going to happen again. 4 minus -2. That's the same thing as 4 plus 2. So that's going to be 6. And then -2 minus 3 is -5. Okay? Again, that is -2 minus 3 is -5. Okay? So that is the answer number 3. Alright, moving on to number 4. For number 4, we're going to do d squared. Okay? Now let me tell you what we're not going to do. I hope you're listening, because back in the day when we had a quiz on this, I had a bunch of kids think that I could just square these individual entries. False. I'm not just going to go 9, 4, 1, 16, 1, 4. That would be wrong. D squared means D times D. Okay, so let's check that out. Alright, so D squared, so this is D times D, all ready to happen. But wait a minute, hold it. This is a 2 by 3 matrix, and of course this is again a 2 by 3 matrix. Is this going to be defined? Can we do this? No. Okay? In order to multiply matrices, the inner dimensions would have to be the same. I have a 3 and a 2, so this is not possible. So I'm just going to put undefined. Okay? Once again, please note that we do not just do 3 times 3 and -2 times -2 and 1 times 1 and so on. Alright, if we were going to multiply d times d, we would have to do the whole thing with elements, right? And you'd have to go, okay, for element 1, 1 would be the first row times the first column. We'd have to be doing that. But there's no way you can take a row like 3, -2, 1 and multiply it by a column, 3, 4. There's nothing to multiply the 1 by. Okay, it doesn't match up. This row and this column have to be the same. So that is undefined. Okay, what about BD? Is that undefined as well? Well, let's see. All right, so this is BD. Okay, BD. So let's do our analysis of the dimensions. This is a 2 by 2 matrix, and this is a 2 by 3 matrix. So first of all, it's possible because the inner dimensions are the same. But second of all, the shape of our answer will be a 2 by 3 matrix, the outer dimensions. So let's go ahead and set that up. Okay, so our answer should be in the shape of a 2 by 3 matrix, which means we are looking for element 1, 1, element 1, 2, element 1, 3, and we are looking for element 2, 1, element 2, 2, and element 2, 3. All right, let's find these elements one by one. Okay, let's see. Better leave some space. So let's start with element 1, 1. That means row 1 times column 1. So row 1, column 1. So row 1 is 2, 0, like this. Column 1 is 3, 4, like this. Okay, so row 1, column 1. So that is 6 and 0, which is 6. So that is our first element, which we can put right in there. So that's 6. All right, let's go for the next one. Okay, the next element. Okay, so let's do element 1, 2. That's row 1, column 2. Row 1 is 2, 0. Now column 2 is negative 2, negative 1. Okay, row 1, column 2. If I multiply these together, I'm getting negative 4 and 0, which makes negative 4. Okay, so that's the next one. All right, so this will be negative 4. Let's move on to the next one. Okay, the next one is going to be, we're looking for element 1, 3. So that's row 1, column 3. So that's 2, 0, and 1, 2. All right, so that gives you 2 and 0, which is 2. Okay, so that's our next element. Okay. All right, let's go find element 2, 1. Okay, so element, element 2, 1. So that's row 2, column 1. So row 2 is 1, negative 4. Okay, column 1 is 3, 4. Okay, so that's going to give us 3 and negative 16, which is negative 13. Okay, so that is going to be negative 13. All right, now let's do element 2, 2. Okay, element 2, 2. So that's row 2, column 2. Row 2 is 1, negative 4. Column 2 is negative 2, negative 1. All right, so that's going to give us negative 2 and positive 4, which makes positive 2. So that is going to be positive 2. Okay, and last but not least, we'll find element 2, 3. All right, so element 2, 3. That's row 2, column 3. Row 2 is 1, negative 4. Column 3 is 1, 2. Alright, if I multiply those together, I get 1 and negative 8. So that is negative 7. So that is the final element. Alright, so that is number 5. Number 6. Find the determinant of the following matrix. Alright, let's call this matrix A. Yeah? Okay, if that's matrix A, then the determinant of matrix A will be found by doing the down diagonal. You know what, that A is bugging me now. Just call it matrix A in your head. The determinant of this matrix will be the down diagonal minus the up diagonal. Okay, so that's going to be negative 20 minus negative 6. Right, which of course means negative 20 plus 6, minus negative is addition, which means we have negative 14. Alright, that is the determinant. That's the answer to number 6. How about number 7? We're supposed to find the inverse of this matrix. Alright, and again, let's call it matrix A. But before we can find the inverse, we have to start with the determinant. You need the determinant to make the inverse. So the determinant of matrix A is, again, down diagonal minus up diagonal. Okay, so we have to do the down diagonal minus the up diagonal. Okay, so when we do that, that's going to be negative 20 minus, negative 20. Okay, and again, minus a negative is addition, so you know this is going to be determinant of A is equal to negative 20 plus 20. Uh-oh, what's happening? What's going on? That is 0. And everybody knows that if the determinant is 0, there is no inverse. So we will just have to say undefined. Okay, there's no inverse if the determinant is 0. Alright, hopefully we'll have better luck on number 8. So if I call this matrix A, once again we have to start with the determinant in order to find the inverse. So the determinant, once again, is the down diagonal minus the up diagonal. So this minus this. So that's going to be negative 12 minus negative 16. Okay. How much space do I have over here? Alright, so that means the determinant is negative 12 plus 16. Okay, so that means the determinant is 4. So there's the determinant. Alright, we're going to need that in order to make the inverse. Okay, now, but we can continue. So the inverse, which we use this symbol for, the first thing we do, and this is why we needed the determinant, is we do the reciprocal of the determinant. So we'll do 1 over 4, which really means that we're going to divide by 4 in a minute. And now, it's time to reverse negate. So when I say reverse negate, I'm reversing the down diagonal, which would look like this. The negative 3 and the 4 switch places. And when I say negate, negating the up diagonal, everything changes sign. So negative 2 changes to a positive 2. And the positive 8 changes to a negative 8. But they stay where they are, they just negate. Reverse, negate. And now it is time to go ahead and do what we said we were going to do. you know, let me stay red. And divide everything by 4. Yeah, okay, so that's why this is going to be 1, all right, 4 divided by 4, and negative 2, and 1/2, and negative 3/4. All right, just divided everything by 4. So this is the inverse right here. Bam! Okay, now let's move on to the next one. What do we have here? Oh, it's one of these area of the triangle things. Let's go. So we're going to use the determinant to find the area of a triangle. So the way we do that is we take these points and we build a 3 by 3 matrix. So we'll have our -6, 2, and our 0, 8, and our 4, -3. All right, to get the rest of the 3 by 3 matrix, we use 1s. So 1, 1, 1. Okay, I'm going to use straight lines instead of my usual squarish brackets, because straight lines mean that we're about to do the determinant. In front here, we're going to put plus or minus 1/2. All right, it's always plus or minus 1/2 when you're doing the area, but don't go putting plus or minus 1/2 when you're not doing the area. This is strictly something that's part of the area formula for matrices. All right, now let's carry on with our determinant. Okay, so the way you can calculate the determinant of a 3 by 3 matrix is to recopy the first 2 columns. So I'm going to recopy there's my -6, and my 2, and my 0, 8, and my 4, -3. I recopied that. And the point of that is to do the determinant, I can do down diagonals, plural, minus up diagonals. Now, you should keep this plus or minus 1/2 going. So let's copy that. Let's keep copying it over and over again. It's part of showing your work. So, plus or minus 1/2 of. Now I'm going to do my down diagonals minus my up diagonals. Okay, so here we go, my down diagonals. There's one, and there's one. All right, those are my down diagonals. So that's going to be -48. Okay, plus 8. Plus 0. Okay, now my up diagonals. Boom, boom, boom. All right, my up diagonals are going to be like this. Up diagonal, and up diagonal. Okay, so that's going to be 32, positive 18, and 0. Okay? So all I have to do is evaluate this, and that's going to be my answer. For now, I'm going to keep my plus or minus 1/2 a little while longer. Okay, but this part on the inside, I'm going to use my calculator to help me. Okay. So what we have here is, all right, I've got -48 plus 8. Okay, and yes, obviously I could do this in my head, especially because I'm the teacher. And most of you can too, but some of you, like in the middle of doing these calculations, this is where you make all your mistakes. And then you'll wind up losing 12 points because you added wrong. So if that's you, use your calculator. At least to check your work, let's say. Okay, so we're getting -90 for the answer. Okay, so this is going to be -90. Now this is where the plus or minus comes in. area cannot be negative. Okay, area must be positive. All right, so you pick whichever one of these signs it takes to cancel this out and become positive. So half of 90 is 45. So that's why the final answer is that the area is equal to 45 square units, whatever those units may be. Please make sure you put positive. If you put negative 45, you're going to lose a bunch of points. Okay, so that's how we use matrices to find the area of a triangle. Excellent, splendid. Let's move on. Wait, right when I saved that, all of a sudden the 10 jumped up there. Will it come back? Do Control Z. Didn't really help. Oh, there it is. That's so weird. All right, anyway, I'll worry about that later. Write a S system. Is that really there? Okay, all kinds of bad things are happening now. A 10 keeps going away. All right, maybe if I go like this, and let's see if I find that 10 and I destroy it, maybe all will be well again. Okay, this is the last problem in the classwork. Trying to get this video done before class actually starts. What? Write a system of equations representing the problem below. Write and solve a matrix equation to solve the system. Show all steps in the process. So this is a typical problem. In fact, I think I copied this from your last test. But this time we're just going to use matrices to solve it. Let's see what we have here. We have adult and student tickets. So I'm going to let A be the number of adult tickets. And I'm going to let S be the number of student tickets. All right, always define your variables. With that in mind, excuse me, this 560 should just be jumping out at you as it's like a one number equation. It's the quantity equation. This comes up very often because we have two different kinds of tickets. We have adult tickets and we have student tickets. That's all we have. But the total number of tickets is 560. So can you use that little bit of information to make an equation involving A, S, and 560? Yeah, hopefully you just sat there and said, well, Mr. Burton, it occurs to me that A plus S should equal 560. If you said that, then you were right. Of course. I've got two kinds of tickets. This number of tickets plus the other kind of tickets have to add up to the total number of tickets that were sold. So boom. Now, the other one should be also obvious for a different reason. Look at what we're talking about. $7 money. $5 money. $3,500 money. Money, money, money. That's a hint to you that these three all belong together in the same equation. All right? $7 for every adult ticket. So that's 7A. And $5 for every student ticket is going to add up to $3,500. Okay? I can't tell you how many times I see some kids going 7A plus 5X equals 560 because they're basically guessing what to do with these numbers. But if you have to guess, why not try to match the units that you have? Dollars plus dollars equal dollars. So if you're not sure, when in doubt, put money and money and money together. Okay, hopefully that'll help you. Anyway, back to the system here. So that's our system, but now we have to turn this into a matrix equation. So we can make our coefficient matrix by going 1, 1, 7, 5. Okay, and then we need a variable matrix, A and S, in that order. Okay, and that's going to be equal to our constant matrix, which is 560 and 3,500. So this is our matrix equation. Most of you are pretty good about writing the equations and then writing the matrix equation. But the stuff I'm about to put in red, many of you leave out. And I'm telling you now, everything I'm about to write in red is mandatory. And when I grade your tests, I'm going to be looking to see, do you have this additional information that's so important? First of all, you need to label these matrices. And let's call this matrix A. And let's call this matrix X, because that's the variable matrix. And we'll call this matrix B. All right, we're labeling it so that we can say the following. All right, maybe I'll keep it going here. Notice we have matrix A times matrix X equals matrix B. Let's go ahead and just write that down. So we have A times X equals B. You must write this. You must label and you must write this equation down, because this is the theory, the theory behind what we're doing. It's the reason why we do what we do. And we have learned that to get matrix X by itself, we can set it equal to A inverse times B. All right? A lot of you are leaving off this red stuff. If you do, it's going to be like minus 6 points or more. It's sort of like when you guys forgot to write X is greater than or equal to 0, Y is greater than or equal to 0, because you didn't really need it to get the answer on those linear programming problems. But yet, it was part of the rubric, and if you didn't have it, you lost 6 points. Don't let that happen again. Write this down. Now we can go on with the rest of the problem. Okay. So to find the answer, we need to do A inverse times B. Fine. Okay, let me just organize my work a little bit. Okay, so that means we need A inverse to be able to do this. All right, we have B, so we need A inverse. So I think I'll just find A inverse over here. Remember, in order to find the inverse, you first need the determinant. So let's find the determinant of A. Down diagonal minus up diagonal. So that's 5 minus 7. Okay, so that is negative 2. Fine. So now I've got the determinant. So now I can go ahead and do the inverse. I think I'll do this in a different color because I'm going to refer back to it later. Let's go with green. Okay, so the inverse, A inverse, is equal to, first thing we need is the reciprocal of this. So that's going to be 1 over negative 2. And of course, the next thing we need is reverse negate. Might be the last time I get to say that. So it's the we're going to reverse and negate. So when I say that, I mean that we reverse the down diagonal and we negate the up diagonal. So reversing these means that we will have 5 here and 1 here. I reversed those. Now negating these means I will have a negative 7 and I will have a negative 1 up there. So this green is my inverse matrix. Okay? All right, this little circle is bothering me. All right, so focus on the green. So we needed A inverse, so we could do A inverse times B. So that is what we're going to now do. So like I said, this is A inverse. So A inverse is negative 1/2 times 5, negative 1, negative 7, 1. Okay, that is A inverse. Okay, and then we have to do times B. Well, B is right here. Just to make it match, I'll go ahead and do that in blue. So I'm doing A inverse times B. So there's A inverse, and here's B. Okay, it is our 560 and our 3,500. Okay, everything I'm doing, every single thing I'm doing has to be on your paper in some sort of organized way. Okay, and so that's going to lead me to the answer. X equals this. So X equals A inverse times B. Now notice I did not divide everything by 2 early. That would make a bunch of ugly fractions. It's easier to multiply these two together first, okay, and then divide everything by 2 later. So let's analyze the dimensions. All right, this is 2 by 2, and this is 2 by 1. So our final answer should be, I really wanted yellow. Our final answer should be a 2 by 1 matrix. Okay, so that means X is going to equal negative 1/2 times a 2 by 1 matrix. All right, so we'll call this element 1, 1 and call this element 2, 1, like we always do. So we just need to find these elements and divide by 2. So let's do it. Okay, let's start by finding element 1, 1. Element 1, 1. Okay, I'm talking about this green matrix here and the blue. That's row 1 times column 1. So row 1 is just 5 and negative 1. That's row 1. Column 1 is 560 and 3,500. Okay, so we're just going to multiply these together. So that's going to be 2,800, and this is going to be negative 3,500. Okay, if I put those together, I'm going to get negative 700. Okay, so that is the value of our first element. So element 1, 1 here is negative 700. You know what, maybe I'll show it on the next step. My friend. So that's negative 1/2. Okay, so I'm finding this. So that's going to be negative 700. Now let's find that other element. All right, the other element is element 2, 1. So that's row 2, column 1. So this is row 2. So that's negative 7 and 1. And of course, column 1 is 560 and 3,500. So row 2 times column 1. So let's see, 7 times 560. That is going to be negative 3,920. And of course, this is 3,500. All right, so that is going to be negative 420. Okay, so that is our second element, is negative 420. So the last step, we just need to divide all of these by negative 2. Okay, so that's why we're going to get X equals 350 and 210. All right, now of course that means because of the way we set this up, that's adult tickets and student tickets. Okay, so A is 350 and S is 210. Don't forget to put your final answer into words like this. And that's it. You can probably hear all the students coming in, but luckily we are done. I will see you on the next video.